let me switch us off. There we go. All right. Here we go. Fast forward it up. What does an RTLS mission mean for the dumb people? Sure. Yeah, Coolio. You know what's funny, dude? I have to constantly remind myself that there's a bunch of new people in here that don't know much about space. So yeah, actually, dude, thank you for reminding me of this. So, RTLS mission. So Falcon 9. Falcon 9 is a two-stage partially reusable vehicle, right? So when a Falcon 9 launches, you have your first stage, you have your second stage, and then you have your payload inside of the payload fairing, right? The whole first stage comes back down. First stage lands. See the landing leg right there? So watch, you'll see it here. There's the landing legs, and then the first stage gets reused. It comes back down and lands. The second stage doesn't, right? The second stage doesn't get reused. It burns up in the atmosphere, or it gets put into a disposal orbit. The fairings come back down and land, right? So when Falcon 9 does a boost back, right, you'll see it right there. The first stage, when it comes back down to lands, it does two things. One of them is a boost back, like what that thing that you just saw was, right? And see, there it comes into landing, and that right there is an RTLS. So if it does a boost back burn, it comes back, and RTLS is returned to launch site, meaning that it lands on the pads. We're going to see that here in a second. That's just a replay, but we'll see this in a moment. The other type of landing is a landing out on the drone ship, the converted barges that SpaxceX has. It was literally the next shot. Yeah. Give it a moment. So that's Falcon 9 coming back down. That's an RTLS. That's a drone ship landing. See the difference? The one is out in the ocean. The RTLS landings are few and far between. You don't see them very often because they want to get more performance. They want to get more delta V out of the first stage. And having the first stage do that boost back burn that I was telling you about, basically where it pulls a U-turn and comes right back down to the launch site, costs more fuel. It costs more fuel to do that. They'd rather use that fuel to push Falcon 9 further and then go and land it out on a drone ship and tow the drone ship back. But today, we got an RTLS. It's not something we get very often. Yeah, there's the double RTLS from Falcon Heavy, right? So, yeah, RTLS landings are really cool because the thing comes back down and lands a couple miles away from where this pad is. It's not something you see very often. Here, I'm going to go over to this side here. I'm fast forwarding us here to get us back up to live here. That's Yume. Yume is an engineer at SpaxceX. She's cool. She's cool. Space is cool. Yeah. See right there, fellas? Actually, all right. So right now, I just say, hey, look at that foundation. Isn't that cool? And kind of assuming that people know what it is. So the interesting thing here is that SpaxceX wants to use pad 39A to launch Starship. 39A has two pads on it now. There's a Starship pad, and then there's Falcon 9 and Falcon Heavy and Crew Dragon's pad. To do Starship operations, you don't want to risk your only pad that you can get people up into space with, right? So that foundation that you saw to the right of Falcon 9 right there is a foundation that they're building for a crew access arm. So pad 40, SpaxceX's other pad that they lease at the Cape, they lease two, 39A and pad 40. Pad 40, they're building a crew access tower for Dragon so crew can launch from pad 40, which is actually really cool.
It's enabling
OneWeb.
our lives.
Airplane.
From connectivity flows a better quality of life, new horizons, and greater...
So OneWeb is a internet satellite constellation. Believe it or not, it's the competition for Starlink. But OneWeb was originally launching on Soyuz rockets, and well, Soyuz is a Russian rocket, so yep, that they needed rockets. They needed launch providers, so they SpaxceX said, we'll launch it for you. And OneWeb's like, are you sure? And they're like, yeah, hell yeah, we'll do that. Sure, absolutely. Competition is good. So, yeah, they're launching OneWeb satellites, even though it's their direct competition. They launch them into space because contract is a contract is a contract, baby. An LR-11350 will be placed next to that white tank where they're to construct the tower. The crane at 39A will likely head over there soon to start building it. Cool, cool. Yeah, so OneWeb is actually competition for Starlink, but yeah, no, SpaceX don't care. SpaceX don't. SpaceX, it's a contract is a contract, baby. Let's make some cash. Yeah, that's cool. It's a really, really, really S tier move from SpaceX. But yeah, OneWeb is an internet satellite provider, and yeah, they're launching on Falcon 9. The core that we're using today, I noticed that core is really, really sooty, so I went and looked it up. That's core 1062. Falcon 9 first stage serial number 1062. 1062, this will be its 13th flight. And it's a 26-day turnaround. Whoa. 26 days. That booster flew less than a month ago. What mission did it fly less than a month ago? Hold on. Hang on. What missions has 1062 run before? So 1062, its first mission was GPS-3 SVO4, then SVO5, then it launched Inspiration 4, it launched Dragon Resilience, a Starlink mission, it launched Axiom 1, so this thing has launched 2 Dragons into space with people on board. Another Starlink mission, NALSAT 301, and then 5 Starlink missions. The last Starlink mission that it flew was on February 12th, 2023. Wow. GPS-3, SVO4, SVO5, Inspiration 4, AX1, NILESAT, Starlink 4.5, 4.16, 4.25, 4.27, 4.36, 5.1, and 5.4. Well, they have achieved the average 4-day turnaround time between all launches to date this year. That's pretty absurd, man. That's pretty absurd. It's kind of crazy to me that this rocket has launched 8 people. That first stage has put 8 people into space. That's really freaking cool, man. It's little stuff like that's pretty rad.
To know a little bit more about the rocket on your screen. Hey everyone, I'm Atticus Federa, and I'm a propulsion engineer here at SpaceX, and I'm excited to join Yome to bring you live coverage for today's launch.
I just want to say how awesome of a name Atticus actually that's a pretty good name.
Two-stage rocket, which stands 230 feet or 70 meters tall.
That's crazy, rocket.
Which is roughly 20 meters taller than the Arc de Triomphe in Paris, France, which is about 40 meters tall. When it's fully fueled, the Falcon 9 will hold just over 1 million pounds of propellant that
nice,
the vehicle
Vistus.
will mostly burn through in less than 3 minutes after liftoff. We began loading those propellants on both stages of the vehicle at just about T-minus 35 minutes.
Is there a set amount of missions where they consider booster not human rated?
Engine chill has started.
So the MTK, the amount of missions that a Falcon 9 first stage can fly is really kind of on a, it's very data driven. So what does that mean? Data driven means that the mission is, it really depends. They don't know how much they could get out of that first stage. There are theoreticals, right? And then there's analytical models, right? So the math will say you could get 100 flights out of a first stage, right? But you're not going to know it until you do it. And NASA's criteria for human rating stuff, or for putting people on a rocket, really, really has to do with the data. You don't go off of your gut, right? You don't do that. Don't be like, it launched 13 times before. It should be fine. No, that's not a good idea. Spaceflight doesn't work that way. You go with data-driven metrics. Basically, the math says that you could get this much out of a booster. You could get this many reflights out of a booster, and then you got to go and do it to basically prove your math. It ain't what you know, Jake. It's what you can prove. So, I'm not sure if that. I was about to say I'm not sure if that has to do with anything, like if the flight rate has to do with human rating the booster, but I would assume that that's probably part of the criteria for stage reuse. Just a guess. Don't know for sure.
To be reflown multiple times with minimal refurbishment between flights. And today's first stage will actually be
MTK. I figured
we'll
that's what you were
land
looking
at
for.
Landing Zone 1, which is not too far from the launch pad. On your screen right now is a live view of that landing.
I mean, the way I look at that, MTK, is that if you're going to human rate Falcon 9 anyway, human rating should the desire to retain human rating for a reused booster probably factors into that criteria. Like, that just makes sense. That's not, why would you do that? Oh, this booster can't move people anymore. Like, see, that doesn't sound right. That doesn't sound right, dude. Because, I mean, believe it or not, dude, I would say that a booster, a first stage goes, it's harder. It has to work harder to move Starlink satellites into space than a Dragon does. Well, why? Well, Starlink satellites are heavier. A stack of 60 Starlink satellites is heavier than the damn Dragon. The Starlink satellites, when they're stacked in there, go all the way up to here. Literally a Greyhound bus stack worth of satellites. I guarantee you that that is not as heavy as Dragon is. Or, those are heavier than Dragon is, excuse me. Did you play the 3 Digirino ads? Oh, we got to do the ad time. Yeah, thank you. Guys, I always run ads before they fly, so people don't get ads during the launch. So I'm going to run them now. Starlinks are heavy, MTK. That's why the Starlink missions need to land out on that dang drone ship, because they don't have the fuel. They don't have the fuel to turn that thing around. Falcon 9 wouldn't have enough fuel to come back to the landing site. Hey, blue guy, black mustache. Welcome to Mission Control. You're a go at Throttle Up. Thanks, man. Dumb question. What is evaporating from the rocket? Not a dumb question, Giffy. This is condensation. The rocket's full of fuel. But unlike the relativity launch that we went to watch yesterday, dude, this rocket is semi-cryogenic. So if you notice, only some of it is condensing. Some parts aren't. What's going on there is that the liquid oxygen that SpaxceX uses is so ridiculously cold that obviously the metal, the aluminum of Falcon 9 is gonna, well, that's gonna push out all the heat. And what's going on is the warm Florida air, which is kind of humid, if it's humid in Florida, the vapor in the atmosphere actually is pushing up against it. And when it pushes up against it, the aluminum skin of Falcon 9 is so ridiculously cold, it actually condenses and freezes the freaking water in the atmosphere. It's freezing the water vapor. It's literally freezing the humidity up against the rocket. Yeah, interesting, right? Hey, Foz, 19 months and Pizza King with a 31. So that's all that stuff that's coming off of it there. It's condensation because the rocket is so cold. But if you look, see right here on the second stage, it's more coming from the top than from the bottom. The reason why, see, like you can see this part of Falcon 9 is not very icy. It's just that part right there because that's the LOX tank and that's the RP1 tank. Relativity the other day, yesterday when they launched from 16, which you can actually see, 16 is right there. You can see it in this picture, which is kind of funny. When they went to launch, they're using liquid methane and liquid oxygen, so the whole rocket was filled up with ice. With Falcon 9, it's not. It's only, well, 2/3 of the second stage and 2/3 of the first stage. You can literally see where the LOX tank ends right there, and then down here, you don't see any condensation because RP1 isn't cold. Now, what's RP1? RP1 is a diesel. It's basically diesel fuel. Actually, it's more like jet fuel. Diesel fuel and jet fuel are cousins in the family of hydrocarbons. It's a actually, it's more like kerosene than anything. A highly refined version of kerosene. So, yeah, she rolls coal. That's part of the reason why Falcon 9 has all that soot on the first stage. That isn't burn marks from coming back from re-entry. That soot is from flying through its own exhaust doing the supersonic retropropulsion. Defense gifted a sub to Old Joe. Thanks, man. How far would you be able to go if you put Dragon on Falcon Heavy? You could do an Apollo 8 style mission with it, Historia. You could do a free return from the moon, but not much else. Also, Chad, in case you want to see why the fairings looks used in sooty, check this fairing entry. Yeah, the fairings. Yeah, see, that's the thing, Rocket. Yeah, the fairings are charred up because of re-entry heating. That's why you can see they replaced some of the fairing right there. They replaced some of the skin on the fairing because entry heating actually cooks those fairings. Well, are we talking about the condensation or are we talking about the vents? The vent line is the gaseous oxygen from boiling, but Aqualex, we are out of time. Let's watch the launch. Let me just make sure we're up to speed.
10, 9.
Perfect timing.
8, 7, 6.
They deliver them by trucks. You can see
4,
the fueling terminals right
3,
there.
2, 1.
Green flash.
Full power. And liftoff. OneWeb 3.
Okay, OneWeb 17. We got a good liftoff on Falcon 9.
Vehicle switching downrange.
Everything looks good.
Stage 1 propulsion is nominal.
Yeah, it caught me. Yeah, that's a 200-foot flame right there, dude. It's pretty nuts. Yeah, no, human space program is great. The
Nominal
simulation,
power and telemetry.
very optimized. Yeah, she's going. You know, I mean, this is a really light payload.
Falcon
so
9 has successfully lifted
should
off
go
from
pretty
Pad
fast.
40 at Cape Canaveral, carrying the
Vehicle is
OneWeb
supersonic.
Launch 17 payload.
The OneWeb satellites are actually kind of light comparatively to Starlink. There's not, yeah, it's not nearly as heavy. That's why they can RTLS.
There we go, call out for that there.
Coming up, or they just hit
At the point of
Q.
max Q, we throttled the Merlin 1D engines down briefly to reduce the loads on the vehicle. We've now throttled
No
the
time
engines
zone.
back up to full power, and this will help us continue to accelerate towards low Earth orbit. The rocket typically needs to go about 17,500 miles per hour.
Yeah.
Engine chill has started.
Okay,
Good call out there for MVAC engine chill.
started thermally
We need to go about
conditioning the engines.
17,500 miles per hour horizontally in order to avoid...
So what they just did with the MVAC engine chill, nice shot. They just started priming the second stage engine for firing, because in another 45 seconds, this thing should be going. Look, you could see the shadow from the plume from the rocket being cast on the ground. See that? See that line right there? That's the shadow from the smoke that the rocket made. Pretty cool.
Coming up on that point in just about 15 seconds here, so let's listen in for that.
Is it turning normal? Yeah, it looks like it is a little bit. Yeah, I know, Karis. Isn't that weird? So we're looking up the business end of the second stage here. You'll see the pneumatic rod push
Main
that
engine
thing
cut off.
away. Watch, there's Miko.
Stage separation confirmed.
SpaxceX has 3 pneumatic rods on the outside and then 1 in the center to push the stage away.
MVAC ignition.
Okay?
Stage
Look, you
one
can see the
boost
first
back
stage
startup.
turning around right there. Watch, that first stage is going to fire its engine. It's going to
And
go
there
this
you go.
way.
You just heard
Watch.
and saw main engine cutoff.
There she
stage
goes.
Separation, stage 1 flip, and second engine start 1.
Look,
Now we are
first
in the
stage
middle
doing
of
the boost
boost
back. You can see the
burn, which
second
you can
stage
see
pull
on
away
the
right
left
there.
side of your screen there. That first stage has flipped around and is burning 3 of its Merlin 1D
You see how the
engines
first
to
stage
head
turned
back
around and
towards
the second
launch site,
stage, the
while
flames
the MVAC
hit
on
it?
the right is pushing the second stage into low Earth orbit. Now today's mission is what we call a RTLS, or
Really
return
cool.
to launch site. And that's actually where we return the first stage back to a landing pad that is actually very close to where we took off from.
So they're landing at
Now
the
this burn should
former
last about 50
Complex
seconds,
13
so
here.
we have about 10 seconds left in the boost back burn.
Does it help flip it? I'm sure there is some type of perturbing force on it, Chillin'. Yeah, sure. I don't think it's enough to turn that entire first stage, but it definitely perturbs it. Boost back burn is done. That white cloud that you see down at the bottom is them purging out the engines. What they do after every engine firing is Falcon 9 uses some of its onboard cryogenic helium to basically purge all the oxidizer out of the engine. The liquid oxygen in the plumbing of the motors can corrode things because oxygen oxidizes. You don't want the engine rusting from the inside out. And pure 100% oxygen will rust something very quickly. So they purge out the engines with helium. And now what they're probably going to do is re-engage the thermal conditioning here when they get ready for the entry burn. You'll see some smoke coming down from the bottom. Now, the nubbin thing right there that's firing, that's the attitude control systems. They're using compressed nitrogen gas to turn Falcon 9 into the proper orientation for doing its entry burn. Now, look, you could see the coast of Florida right there. How about that, huh? All the way down to Miami. Actually, it looks like Miami's right there. There's Satellite Beach. Actually, no, Miami might be over. It's hard to tell. I can't really tell with the clouds. But you can see the coast of Florida right here. It's easier to spot it at night, I'll be honest with you. Let me just get my bearings here.
Now we do the entry burn in order to slow down to reduce re-entry forces, which helps us to recover and
Moon,
reuse
they have
our
to,
first aid.
they hit the engines with helium, with some of the cryogenic helium. Yeah, okay, so there's Miami. That's Miami right there. There's Satellite Beach right there. There's Cocoa Beach. That's the Banana River. Port Canaveral should be right behind those clouds, which means... Oh, there's a shot looking up. Note that the pneumatic push rod to push the second stage out has retracted. There's Port Canaveral right there. That's Port Canaveral. So there's the lighthouse. That's Complex 36 right there. See those dots? Right there. That's the landing site, right where the tip of my mouse cursor is. That thing's going to come down right there. There's Complex 39. That's 39A, 39B. There's the shuttle runway right there. Cape Canaveral skid strip is right there. Cape Canaveral Space Force Station is right there. And, well, there's Titusville over there. The landing sites are right underneath the booster right now.
Start up.
Here comes the entry burn.
There is the start of the entry burn.
So what this is doing is basically pushing the re-entry heating away from Falcon 9. They fire the engines, and they use the outgassing from the engines to give Falcon 9 a good thermal medium. Because when
Stage 1 entry burn, down.
when it comes back down and hits the atmosphere going 4,000 or 5,000
entry burn
kilometers an
from-
hour, you're going to get some re-entry heating. But they fire the engines to push the plasma away so it doesn't cook Falcon 9 on re-entry. Supersonic retro
You can see
propulsion.
those attitude control thrusters on the first stage.
Port Canaveral's
firing
right there.
Both vehicles continue to follow nominal trajectories.
Causeway is right there. There's
first and
ITL.
second
The
stages
pad it
are
launched
looking
from is right
good.
over there. So what Falcon 9's going to
And
do
our
is
next milestone is
it's going to
the
use the
stage
grid
one
fins to
landing
basically fly over the landing site, and right when it gets over the landing site, it'll fire its engines and just come right back down.
About 15 seconds here.
Stage 1 transonic.
You can see as this thing gets down lower into the atmosphere, you see it shaking around.
Stage 2 FTS is
That's
saved.
that's the air pushing up against it. It's causing insane amounts of drag. But you
Stage
can
one
see the
landing
aero
burn.
load on those grid fins gets really, really
Start
high.
of our
There's the
stage
landing
one
pad
landing
right there.
burn.
Oh!
That's great drone footage of the first stage that you can see on the right-hand side of your screen.
Oh. Oh.
Incredible views from first stage coming down on
Stage
landing
1
zone
land and let
one.
deploy.
Well,
It was a beautiful
Stage 1
landing.
landing confirmed.
well then.
Beautiful landing of the first stage.
That
and
was
there you
neat.
have it. That landing marks
Stage 2 is
space.
in terminal guidance.
Dude, that thing was
That landing marks
right on the
SpaxceX's
money.
177th recovery of an orbital class rocket, including the first stage landings of Falcon 9 and Heavy.
I've seen them land
And
with
now
my
back
own
to
eyes,
stage
freaking.
two. Stage
No,
two is
it's
looking
legit.
good,
They
with
do.
just
Those
about
stages
10
come back
seconds
down.
Left before second engine cut off one.
What do they do with the second stage? Second stage will be disposed of, Okami. They'll deorbit it and it'll burn up in the atmosphere. Is that Jesse? It's Yume. Yume is doing the cast today. Yeah, Ordon, that shot on the right from the drone coming back
back
down was pretty
shutdown.
good.
Heard that call out for MVAC
Oh.
shutdown.
Yeah, there's that polar corridor that we were talking about.
We're just waiting on confirmation of a good order.
Nominal orbit insertion.
You
This
just
is
heard that
that's
good
the
call out
13th
for
landing
nominal
for that
orbital
one.
Insertion.
NOI.
The mission
nominal
isn't
orbit
over yet.
insertion.
The second stage is now embarking on its first coast phase.
Yeah.
Now,
that's
after this
that's
coast
polar
phase,
out of the
we will
polar
relight
out of
that
KSC.
MVAC engine for a second time around.
So somebody said that they're burning slightly anti-normal.
Back here in
Or
about 45
actually, that would be normal because they're going south. So yeah, Falcon 9 took a right-hand turn during ascent. It went out to the east initially and then took a right after that to go out and around Florida because you don't want to fly over Miami or Fort Lauderdale. That would be... If something went wrong, that would be pretty bad. You don't want to do that. So it stays out over the ocean and then follows the coast of Florida. So the interesting thing is, Car Toys, is that the landing legs on Falcon 9, they have to wait until the booster is going below like 100 knots. If they don't, aero forces will just push them right back in. I learned that from trying to do that in KSP. Yeah, you have to wait until you have to basically wait until the last second, right when you go below like 120 knots, or else, yeah, the aerodynamic pressure forces that are on the landing legs when they deploy, they would push them right back up. They would overcome the hydraulic, the flip mechanism. They did Drift King. Yep, you know what DK stands for? Donkey Kong? No, Drift King. Yeah. Well, this is a customer mission, Everest. This isn't Starlink. This is OneWeb. So yeah, they'll go all the way to deployment. Wait, this was expendable?
Sonic.
No.
Stage 2 FTS is safe.
So this is a replay from just a second ago. This drone shot. Watch this one, S.
Stage 1 landing burn.
Start of our stage 1 landing burn.
Dude.
That's great drone footage of the
Dude.
first stage that you can see on the
Dude.
right-hand side of your screen. Incredible views
Dude.
from first stage coming down on
Stage
landing
1
zone.
land and let deploy.
That was a beautiful
Stage 1
landing.
landing approach.
Yeah.
Beautiful landing
Panther,
of
we
the
did.
first stage, and there
You saw the T-tab
Drone.
ignite.
Stage 1 landing burn.
Yeah, watch it again.
start of our stage.
See? Takes a second. It takes a second for the turbines, for the turbo pump to spin up, and then
Landing
boom! See ya.
Great
That's
drone
so cool.
footage
It
of
takes a second for the
first stage
turbine
that
to
you can
spool.
see on the right-hand
Yeah,
side
that's
of
what
your
that green
screen.
flash is. That's the igniter fluid. Unbelievable. So those stripes that are on
views from
Falcon
first
9 are where
stage.
they're inspecting the
Coming down
welds.
on
They
the
x-ray the
landing
welds
with
after
deploy.
every flight. Then they have to clean off the soot. That's why there's lines there. Those are welds where they welded the aluminum panels together.
That was a
Every time I join the stream, there's another SpaxceX launch. Kem, they're launching every 4 days on average. Every 4 days, dude. I know you've been out of the loop. SpaxceX has launched... This year, they've launched 17 missions. Well, this is the 16th. Yeah, 16 missions already. That's absurd. It is absurd.
beautiful landing
Stage 1
of
landing
Can I just...
approach.
Can I...
incredible views from first stage coming down on
Stage
landing
1
zone.
land and let deploy.
What percentage
That
of them are
was a
Starlink? The
beautiful
vast
landing.
majority of them are, Josh.
Beautiful landing of the first stage, and there you have it.
Let's go back up to live. The grid fit, yeah, did you see them turning, Ark? They turn, and then at the last second when you're going below 100 knots, they freeze the grid fins, and that's when the legs deploy. That's what I always watch for. When the thing comes down to land. Here, let's go back. The grid fins are doing
Great
work,
drone
right?
footage.
They're doing a ton of work here. You look at how shaky it is, right? You can see the grid fins actually turning and guiding Falcon 9 in. And then when it slows down, basically to the point where the grid fins aren't effective anymore because you basically stalled, right? Because the rocket engine's pushing, the grid fins freeze. And right when the grid fins freeze, that's when the legs deploy. Because you're going slow enough so the aerodynamic forces don't push the legs back up. Isn't that the highest sustained launch cadence ever? I don't think anybody's gone this crazy at Mana. Maybe in the early 60s, dude. What do you think about the theory of exponential satellite crashes closing us off from space? That's Kessler syndrome. And that Kessler syndrome is absolutely a thing, Atlantic, and we have to be careful. Part of the reason why Space Force was made the Space Force was to make sure they get on that. Yeah, yes, that's funny. Can't be done. It's probably because it was a polar launch corridor, Aqualex, the slew. It does jump. Is that normal? Yeah. Yeah, high vis, yeah, I saw it. It kind of settled for a second. Sometimes you get a little bit of residual thrust in the motor. Think about it like if you look real close here when that first stage comes in, it bounces a little bit. That's normal. Sometimes you get residual thrust. So think about it like if you have a sprinkler running, like you have your garden hose, right? Garden hose going all the way to the sprinkler, and you shut the garden hose, you turn it off. There's still water in the line, and you'd have to wring it out. And if you like pick up the sprinkler, it's going to shoot water everywhere, right? Same idea. So, but instead of the sprinkler, it's a rocket, and some of that when you shut the rocket engine down, sometimes the rocket engine burps. It burps that residual thrust, just bleh, and you get a little bit of bouncing up and down. It does happen. Yeah, that's normal. You could see Vulcan when they showed Falcon 9 on the landing pad. Hey. Huh, that looks familiar. So that's Terran 1. There's Relativity. That's Relativity's pad. We were watching that pad for like 3 hours yesterday. There's the pad. That's Relativity. There's Terran 1. It's right there. Slick 37 is behind that, and Slick 41 is way over there. Yeah, it just burps, Joe. That's what happens, dude. What do they need to do to reuse... What do they need to do to reuse Stage 1? How long does it take? This one was turned around in 3 weeks, Jabba. Yeah. What do they need to do? Inspect the welds. Inspect the tank welds. Make sure that they're not cracked. That's what those lines are on Falcon. Like, you can actually really see them right here. See the inspection lines? They're inspecting the welds between the tanks. You can literally see the aluminum panels that they welded together. They stir welded them. They're looking for cracks. That's what those lines are right there. See all that? They're looking for cracks on the booster. Saturday at 1, Synerd, is when they're going to try. The Claw is a big one, Hellfish, but yeah, I'd be interested. Yeah, this thing flew on February 13th. That was the last time it flew, which is just absolutely insane. Here, let's get back up to live. It's going to take a second to get to the deployment area. This is John Krause. John Krause is a photographer and the content director for the Polaris program. But yeah, he got some... Oof. Great pictures. Wow. Real nice. It's a pretty picture. John is real good at what he does, let's say. Yeah, Aqualex. Yeah, you could. Yeah, that'd be. I mean, an extruded aluminum tank. Yeah, we're a little bit behind, huh? They're gonna launch on Saturday, Munch. They'll get it right, sure. See, I was thinking about this, dude. So Relativity yesterday when they went to go, they couldn't get the propellant temps right. Now, the thing is that they initiated the auto sequencer. They went into the final hold at T-minus 70, and they tried to initiate the auto sequencer, and the auto sequencer immediately aborted. Immediately. So there could be... The thing is that... Well, here's the thing. It could be the parameters that are set for the auto sequencer. So... The temps that they had inside of the tank might have been just fine. But if the auto sequencer isn't configured correctly, it might think it's not fine. So it could be the parameters for the sequencer. The sequencer could, you know, in testing, maybe it showed like minus 290 for LOX temperature instead, and you know, they were at minus 292 or 293, right? If the parameters aren't set on the sequencer, they're gonna have to fix it. Well, not fix it. They just change the software around a little bit. Now, why would minus 291 versus minus 293 be a big deal? Well, 293 is when oxygen turns to liquid, minus 293 Fahrenheit. So they could have had the parameters for the auto sequencer not configured correctly, and the prop temps could have been fine. It's possible, but that's why they scrubbed for a little bit, and they're probably, I bet you they have it figured out by now. I'll bet you when they try on Saturday, barring there's no other problems, I don't think prop temp's going to be an issue. Yeah, Rocket Guy, the flip side of that is what you said. The flip side of that is that if the auto sequencer parameters aren't done correctly, then it's not that big of a deal. That's really easy to fix. It's literally just changing some values in the software, right? The thing is, the flip side of that is if they did the math out, and the math said that if they flow LOX at this rate into this tank at this time, it should yield this temperature inside of the tank, and that temperature is not what the math is showing, that's a problem. That's an issue. That's a big issue. Because that means somewhere when somebody was doing the analytical models for launching the rocket, that means someone did a Michael Bolton. They screwed up some mundane detail. That's not good. That's not good at all. Now, granted that they did a mission duration firing on the second stage, and they've done a full duration firing on the first stage. I'd be inclined to say it's more auto sequencer than anything. But you never know. There's always some risk, and there's always some doubt with, you know, the first time you put the whole rocket and do a full stack test. Full stack in terms of software, and full stack in terms of a fully stacked rocket, right? There's always a little bit of risk. You're not going to know if it's actually going to work. I mean, the math can say it can work. That's fine. You know, but if somebody didn't tighten a bolt down on the rocket, the math, great. The math says it works. Somebody didn't tighten a bolt, the thing blows up. You know, there's always risk. There's always a risk on a first flight. Every time. Do you know any must-need part mods for KSP? Eddie, I played my entire KSP 1 career with 0 part mods, dude, to be honest with you. PC load letter? What the frick does that mean? Yep. What's that, Zay? They could have done a Dave. Nice. What's so good about OneWeb? Just more broadband for everybody? It's competition for Starlink, and competition will drive the industry. Absolutely. It's a good thing. That's why SpaxceX literally is the competition for OneWeb with Starlink, and they're still launching it. Cool, Erudite. Neat. Nice onboard shot right there. Right now, stage 2 is just to the west of the Andes. Skirting the coast of Chile. How long will Starlink and OneWeb sats orbit? OneWeb will stay up there a lot longer than the Starlink sats. OneWeb's operational lifetime is a lot longer. Starlink satellites only last five years. Why aren't we able to see any stars in the background? Gloria, are you actually asking or are you trolling? Because people troll me with that question all the time. If you're actually curious, I can tell you. just let me know, dude. Is it both called Andy? Oh, they said you were good. Yeah, I saw it, Panta. We just looked at those pictures on stream. So, guys, here's the thing. All right. So, Gloria, you know, I'll just. Well, tell me, why can't we see the stars? All right. People are curious in it. Okay. So, you have this map view, and the map view, you see all the dang stars in the background, right? So, the reason why you can't see the stars in the background is because, well, there's one star. You can see one. You can see the light from one star. That one star just happens to be a lot closer than all the other stars. And it's washing out. It's washing out the camera. It's camera exposure. You can see stars in space, but the camera lens has trouble picking it up. You ever, like, take a picture in the dark with your phone, right? You take a picture in a dark room with your phone, and you can see just fine. And then you take a picture with the camera, and it just shows a black screen. Literally the same thing. Right? Astronauts on the ISS can see the stars. They can see the stars at night. In fact, you could see pictures of them looking. If you go look on YouTube, you can see pictures of astronauts on the ISS looking out the windows and seeing stars. That's around somewhere. The problem is that when you're in the daylight, there's one star that's a lot closer than everything else. And that one star tends to wash everything out behind it. Think deer in the headlights thing. You know, if you have one car coming at you, right, and the lights are shining right at you, you're not going to see anything else around it, right? You ever been in front of a car at night? Hopefully it's not coming at you. Right? Hopefully it's just parked. If you see the lights on a car, you can't see anything behind it. Same idea. There's just one star that's a lot freaking closer. Well, relativity seems to think so, Aqualex, yeah. It's pretty much the same reason you can't see stars during the day. Yeah, there you go. Yeah, Glory, I mean, that's it. Yeah, exactly. That's why people stargaze at night. It's literally the same reason. One star is a lot freaking closer than all the other damn stars, and it's really hard to see what's behind it at night. Or not during the day, not at night. Yeah, I mean, that's why it's the same reason why during the Apollo program, why you can't see any stars in the background, because the sun is literally destroying those cameras. You can't see you could try to adjust the camera shutter speed or do a long duration exposure, right, to see the stars in the background. I bet you that would work. But yeah, that one star is going to wash everything else out. That's just straight photography, guys. How much light gets into the lens is how bright the picture is. You know what I mean? It's kind of a pain in the butt, dude. For astronomers, you have to go out at night with the telescope. I mean, in space, in this type of orbit that they're in right now, 361 circular, give or take, in that type of orbit, yeah, when you're on the dark side of Earth, so when Earth is eclipsing the sun because you're behind it relative to the sun, oh yeah, you can absolutely see stars. Sure. Oh yeah. I wonder if the onboard cameras would be good enough to see stars during a light night. We've seen stars in the background when they launch at night. Absolutely. So is Hubble always on the dark side of Earth? No. Hubble is in a low Earth orbit, Atlantic. They take pictures when it's on the dark side. Yeah, and they probably would if they adjusted the exposure right. But you got to remember, these cameras on board are engineering cameras, and they're really designed they're nearsighted, is the right way to say that. They're really nearsighted because they're designed to look at the turbine machinery and stuff in detail. So these cameras they're not really good telescope cameras. That would be like trying to host a television show with like a CCTV camera, like a security camera, the ones that all pixelated out. It's not really designed for that. It does work, yeah. Use lithium, it works, but the guys on the ISS have like an 800 millimeter lens and a DSLR. This is not a DSLR right here. This is just an engineering camera. In fact, it's probably something that's just good enough so they can tell what's going on, and that's about it. How long until deployment? About 15 minutes. How much is gravity slowing it down, or is there another force? Or is it another force? Well, gravity wouldn't necessarily slow you down, Flyboy. Changes in gravity will slow you down. You know, despite what, there's all these people going around saying the Earth is a perfect sphere. It's not a sphere. No, the Earth is basically a big jello mold. It's a big jello mold. And it kind of weeble wobbles around. Earth has a 27-degree axial tilt, and it basically spins like this. Just weeble wobbles all over the place. And because we have a molten core, right, that's just kind of all shifting around all inside, all over the place. Literally like a big jello mold. It's, that's why we have plate tectonics, guys. So if you want to get into geology, that's why earthquakes happen. That's why, the continents shift around and stuff. That all happens because, we're basically floating on the cool crust of a gigantic jello mold. And in that regard, Earth is not a perfect sphere. So, like, if you took Earth's shape and you went to the geographic center of the Earth, the center of gravity is not exactly coplanar with the center of the geographic middle of Earth. The center of gravity is like over here. It's a little ways off, so Earth kind of weeble wobbles around. Think like if you spin a top and it starts going too slow, it'll start doing this. That's literally what Earth is doing. It's the same exact idea. And it causes a precessional force, all right? It causes, because of the non-uniform gravitational pull, right? And this isn't something that like, oh, science said it. No, if you go to like Antarctica and you drop a rock and you have a really, really sophisticated timer, and then if you go to the equator and do the same thing, the gravitational pull will be slightly different. It's not that much, but it is slightly. It's not a lot. Don't get me wrong, because you're for the most part still kind of the same distance from the center of gravity, the Earth, right? But it will be different. That's not like, wow, I have a theory. No, that's been observed. That's absolutely a thing. So because of Earth's non-uniform gravitational pull, you get a precessional force. So basically, if you just keep orbiting around Earth, right, eventually Earth's non-uniform gravity will pull you back in. Object in motion stays in motion unless acted upon by an outside force, right? Just simple laws of physics that you can test by throwing a freaking rock around your backyard, So those non-uniform gravitational pull can actually pull satellites back in. So now that doesn't, what's more likely going to get you on Earth is the atmosphere. Even up at 420 kilometers, nice. So this is about 270 miles up. Even up at 270 miles, 400 kilometers, you're still going to encounter some atmosphere. Earth's atmosphere doesn't just stop. It's not planet Druidia, okay? Like 1-800-Druidia. Psh, open the combination to the air shield. It doesn't work like that. Earth's magnetic field is holding those, and coupled with gravity, is holding those gases in place. The magnetic field does a lot of it, but gravity pulls the gases down too. They pull air down just like they would pull this water jug down if I let it go. Same idea. But it doesn't just stop. Traces of Earth's atmosphere have been observed as far out as the moon. Oh yeah, it's out there. It's just not enough to breathe. There is air up there. I wouldn't try to take your helmet off up there. That's probably not a good idea. Yeah, you probably shouldn't do that. So even up here at 270 miles, you're still skirting part of the atmosphere and it's causing drag. You're still flying technically, right? There's still air up there and that will slow you down. So the precessional forces of Earth and aerodynamic drag will eventually bring this thing back down. Even at 400 kilometers, that's still a decaying orbit. It'll still come back. Password is 12345. So the interesting thing is, and I usually do Kerbal streams, guys. So we play a lot of KSP. If you put something in orbit around the moon in KSP, it'll just stay there indefinitely. But in real life, the moon is the same way. The moon isn't a perfect sphere. It's not a perfect sphere. It's kind of more like a weird kind of almost symmetrical rock. But a moon is the same idea. Part of the reason why the moon stays tidally locked, right? Why the moon, one side of the moon is always facing towards Earth, is because the center of gravity of the moon is offset. It's not in the exact center, right? It's like over here somewhere. And that same precessional force that happens with Earth can happen on the moon. And you can actually have decaying orbits on the moon. That absolutely is a thing. You leave something in orbit around the moon, it will eventually, the moon will pull it in, just like Earth. Pretty cool, huh? Any planetary object spherical? No. I mean, habitual, you know what? I'm not going to say no, because I don't know that for sure. There's nothing in our solar system that exists like that. Nothing is a perfect sphere. Nothing. Not even close. Thank you for the very informative discussion. Yeah, I got you, Flyboy. All good, man. Yeah, this is like, and once again, fellas, this is not like some crazy abstract concept. You could go in your backyard and take a rock and you throw it. If you understand why that's doing that, you can understand why a spacecraft does what it does. Because the spacecraft, all it does, if you throw a rock, the Earth's gravity will pull it in. But if you give that thing enough acceleration, it can overcome that force of gravity, right? And if it overcomes that force of gravity, you just fall around the Earth and you just keep going. But object in motion stays in motion unless acted upon by an outside force. That outside force that you have now once you're in orbit is the aerodynamic drag and the Earth's gravitational precession. The crazy thing is that, you know, you think of that precession as a debilitating thing. Like, oh, the Earth's precession, non-uniform gravity, it's going to pull the satellites out of orbit. That sucks. That's so annoying, right? There's a type of orbit that you can get into called a resonant stable orbit. This type of orbit will basically make it so Earth's precession, believe it or not, counteracts the aerodynamic drag. There are types of orbits that you can get into that will stay up there indefinitely, where the non-uniform gravity can actually work to your advantage. It can boost your orbit. And so any drag that's lost from skirting the atmosphere, right, can be regained by the Earth's gravitational pull. Which is nuts, right? Like, you can use that to your advantage because the drag's always going to be there, but the precessional force, you put yourself into the right type of orbit, it can counteract it and you can make something that's resonant, something that'll just stay up there. Any drag that you get from the atmosphere can be basically offset by the non-uniform gravity of Earth, that's crazy. I think that's really cool. Now, another thing that they use precession for is to shift an orbit about its axis. They can use that to change an orbit, right? There are certain types of satellites that go into an orbit called a sun-synchronous orbit, which is called an SSO orbit for short. SSOs use Earth's precession. They use the non-uniform gravity to actually shift their orbital track. They change an orbital parameter called longitude of ascending node. Basically, you know, Earth is kind of spinning, right? Earth is spinning, and you can use the gravity to actually shift your orbit, right? And if you time it correctly, you can make a sun-synchronous orbit. You can make it so you can use the precession, right, coupled with the type of orbit that it's in, to basically have the satellite fly over the same destination every day at the same time while the sun's out. Now, spy satellites are in those types of orbits. That's where I'm going with this. Spy satellite. I have no better way to say it. You know, a type of orbit that uses the precession to go over the same point at the same time every day, like at noontime, right? If you time it correctly, satellite in a sun-synchronous orbit will fly over your enemy's missile sites, for instance. You know those satellites that they, you know, in the spy movies, like, oh, you know, we have another satellite coming into range now. Yeah, those. That's what they're talking about. Like the enemy of the state ones where they zoom in. You can see, oh, the satellite's going. Yeah, that's what those are. That's where those are. They're sun-synchronous. They use that precessive force from Earth being a non-uniform sphere to image the same spot every day. That's where the spy satellites are. This is not a religious question, but have you ever thought about how niche and perfect everything about the way of life in our solar system works? Gravity, physics? Yeah, Keenblade. That's the thing, dude. It's not. It's absolutely not. Not to get like too existential here, but the Earth is not a perfect sphere. It's a wobbly freaking jello mold. It's a violent and dynamic environment. Space is even crazier, dude. Everything in space is trying to kill you. at all times. That's why spaceflight is so hard, especially when you put people on there. Everything in space is a wild, chaotic freaking place. Sounds a lot like Earth to me. That's how I know it's legit. You know, like that's how I know, like, dude, if they said like the sun is a perfect sphere and the Earth and the moon are perfectly aligned, I'd be like, yeah, okay, guy. You know? You know? I don't mean perfect. I mean everything is so imperfect yet works together. It is just a violent freaking balancing act. Yeah. I mean, the fact that Earth exists is pretty crazy, dude. There's no other planet in our solar system like this, dude. But that doesn't mean that there can't be other planets like this that exist out there. But yeah, I do see what you mean. Like, I think that deals more with, like, dude, the fact that we even exist is kind of ridiculous. Because when you look at something like Venus, you know, and you look at something like Mars, like, our planet could easily be like one of those. Like, it wouldn't take much to make it like Mars, where it's basically dead. Or make it like Venus, where it's basically trying to kill you all times. I mean, Earth kind of is. It's kind of more like right in the center, dude. There's a reason why they call Earth the area where like Earth and Mars are is, believe it or not, called the Goldilocks zone. It's not too hot, not too cold. But even Venus and Mars are skirting the outer edges of that Goldilocks zone. Earth is right in the center. Yeah, it's kind of crazy coincidence, right? And I don't blame people if they think, they look at that and they go, yeah, okay, you know. But yeah, no, it's pretty nuts, dude, right? Yeah, I mean, Keen, I see that. The fact that everything is so ridiculously imperfect, and I see like that, yeah, dude, that makes sense in my mind. If space was some perfect, ideal place like heaven or something, right, I'd be like, okay. Moon is part of evolution. Without it, life would be different. That's right, Fire. Yeah, if we didn't have the moon, oh yeah, dude, it's, yeah, nuts, right? Never take our existence for granted. Yeah, good call. Good call. Yeah. Now, Keenblade, I understand what you're getting at. Yeah, it is kind of nuts, right? That, dude, I see something like that, and I see like, wow, that's very humbling. You know, like what Slackster just said in chat. That's super freaking humbling. It's like, bro, we are lucky to be here, man. We are lucky to be here, dude. So, you know, it keeps you, you know, it's kind of one of those things that kind of puts it into perspective. You're like, okay, all right, I'm not going to be a dick today because this could all just get blinked out of existence with an asteroid in the right spot. We should probably be careful there. Yeah, Boxy, that's important to say. Yeah, it's for carbon-based life. We're in the Goldilocks zone. Yep. It's very humbling, dude, indeed. And if, you know, people see this and their brain goes, huh, and they default to a higher power, I don't blame people for doing that either. That's, yeah, no, I'd be like, yeah, okay, yeah, no, I get you for sure. Satellite still not deployed. We should be coming up on deploy here in another couple minutes. Are you staying nice and hydrated? Of course. Why do the orbits look like an S on the map? They show flat and then show flat on these displays. That's a good question, Huzfat. Yeah, okay, so if you're looking at a ground track on a two-dimensional plane, the orbits look sinusoidal, right? But the crazy thing is that's just an inclined orbit. A polar orbit would have way higher amplitude over that map. An equatorial orbit would just be a flat line. So if you were following Earth's equator, it would just be a flat line. There wouldn't be any amplitude, no wavelength, no nothing. Now, the reason why you get that sinusoidal shape, so it looks like a squiggly line, is because you're taking Earth's shape, which is an oblate spheroid, and you're trying to project it on a map, right? So try to take a piece of paper and like a basketball or a soccer ball and try to wrap that piece of paper perfectly around it without crumpling anything. You can't. Surface area and stuff, man. That's why on a 2D map, the orbits look like a squiggly line, because you're trying to overlay a 3D environment onto a 2D screen. So you end up getting a ground track. That's what that's called. It's called a ground track. Did we get ad time? Yeah, of course. Why is SpaceX helping a competitor? Because if they're gonna pay you, who's really losing? Probably flagging, yeah. Because the green, man. More competition is better for the commercial satellite industry. That's why SpaceX is launching their competition into space.
Discovery.
Because
Go
SpaceX,
throttle up.
because the guys at SpaceX know. I mean, first of all, OneWeb's not doing it. They're not doing it for free. They ain't doing that out of the goodness of their heart. OneWeb's paying for it. Second of all, having competition in space like that is going to drive the orbital launch industry for long-term profits. Both the OneWeb satellite network and Starlink both need to be maintained. That's going to create an increased demand for launching things into space. Which is smart, man. That's actually a really good idea. It's like a 5D chess move. Keenblade, still my favorite space and science streamer to date. Thanks for always teaching us. Your descriptions and analyses really help anyone to understand these concepts. Keep feeding you and much love. Right on, man. Thanks for the 2-month resub. And Grizzly with the 26er in there. Thanks, guys. Appreciate the support. Yeah, Flykin, that's cool, dude, but that doesn't excite joy in my heart, dude. Yeah, there's all these different exoplanets out there and just planets in other solar systems that could be like Earth. They use gas spectrography to figure out the atmosphere, right? But that's not really gonna like get me super hyped until we have some type of technology that can actually get us there. How's Fathend? Welcome to Mission Control. You're going throttle up. Thanks for the prime sub, dude. Should be getting up onto the deployment sequence. Now, keep in mind, there's like a bunch of OneWeb satellites on board, so the deploy sequence is going to take a little while. Yeah, Danzu. Maybe. Nice picture, Eddie. Good job, dude. See, you can do it, dude. It just takes time and practice. SpaceX needs as many launch contracts as they can get. They are trying to expand their $7 billion launch segment stake. Bingo. All right. But yeah, this is the OneWeb 17 mission, guys. We're coming up to second stage engine start 2. And then right after that, second stage engine cutoff 2. And then, once they're into the proper orbit here, they will start deploying the satellites. The OneWeb satellites are anywhere from 500 to 550 kilometers. Some of these satellites have their own, well, not some of them. All of them have their own little propulsion system on them that'll get them to their final orbits. DJ on Lex Freeman podcast when? What has he done to deserve me? Question, does something with larger weight or mass orbit slower or faster? So, Keen, weight has nothing to do with it. It's mass. Mass of something. Like how much of it is there. Weight is measuring the gravitational acceleration on a mass. Okay? Basic physics, dude. So, does something with larger mass orbit slower or faster? No. 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 You could have a 100-ton brick of concrete and a piece of paper. And if they were going the same speed around Earth, yeah, they would be, yeah, you need the same amount of delta V to get into space. You need the same amount of acceleration to get it up there. Now, don't get me wrong. The 100-ton brick of ball of concrete, right, is going to need a much bigger rocket. Yeah. Oh, yeah, you're going to need a bigger rocket to move that. Rather than moving a piece of paper up into space. But space is all about, like, spacecraft range and stuff is measured. Range is measured in acceleration. It's all about the speed. So how fast can you push said mass? If you have a rocket that can accelerate that 100-ton brick of concrete, right, to 17,500 miles an hour, well, guess what? Then you can get that into space. But its orbit will stay pretty much the same as a piece of paper in the same orbit. Now, here's the thing. Those perturbing forces that I was talking about will have effects, right? But provided, say, just for instance, Earth was a perfect sphere, right? Perfect sphere, center of gravity's right in the center of the Earth. No atmosphere, right? And it's a perfect sphere. There's no precession, no aerodynamic drag. Yeah, they'll both stay in the same orbit. They'll just stay there until acted upon by an outside force. That's it. Now, once again, on Earth, it gets a little bit more complicated. That piece of paper, right? A piece of paper will probably stay up there for a lot longer period of time. Well, why? Well, because a big 100-ton ball of concrete or a brick of concrete is going to create a lot more drag than that piece of paper because it's freaking huge. Spherical cows and whatnot. I've seen that before, Alex. That's a sweet billboard. Why does Voyager need a spin a few RPM but not satellites in the ISS? It's spin stabilized, Violent. The spin stabilization will keeps the dish pointed at Earth. If it's spinning, right? If it's spinning along its axis, it's think about it like a bullet that's rifled. Same idea. It keeps it going in the right direction, keeps the dish pointed at Earth. Makes perfect sense. Right on, dude. Yeah, you got to think about delta V, dude. Delta V is how, like, we measure spacecraft range. The more delta V you have, the further you can go. But your delta V will change depending on payload mass. So if I have that same rocket that can move that piece of paper into space, what does the paper weigh? I don't know. Nothing. It's a negligible amount, really. But it still has mass, right? With the piece of paper on board, right, our small rocket can put that paper into orbit, right? Because it has enough change in velocity. You could change velocity more, right? If you put that 100-ton brick of concrete on that same small rocket, now you don't have enough delta V. Not even close. Because you just drastically changed the total mass of your rocket. If the ISS spun, the astronauts inside would get thrown around. Something bad would happen, Gerald, for sure, yeah. So why does the ISS not spin? What rocket guy said? The ISS has... The easy answer to that, Violent, is that the ISS does spin. Only parts of it does, though. On the Z1 truss segment on the ISS, you have control moment gyros, CMGs. They're spinning. But it's a gyroscope, and that keeps the ISS on an even keel. It always keeps the truss segment parallel to the ground. CMGs help keep that moving. Yeah. Part of it's spinning, not all of it. Angular momentum do be like that, though. I don't want to watch it, Spaceman. State of NASA is just them. It's so self-satisfying, dude. It's cringe to watch. I'm not watching it. I'll get the cliff notes later. Yeah, massive CMGs. Yeah, there you go. You want to see the size of it? And there's 4 of them in redundancy, dude. Here, take a look. Yeah, Rocket Guy, that's a great picture. There's one of them. There's 4 of those things. That's right, yeah. That's right. This is high school physics, dude. Now, the thing is like, I didn't pay attention to high school physics. I had to go and relearn all this stuff later, and that kind of sucked, but yeah, there you go. Right over here. Looks like they're unpacking a new TV. Yeah, watching, yeah. Think about trying to take a TV out of the box with boxing gloves on. They had a reacquisition of signal there, the camera glitched. Bruh. In space, yeah. Working on the ISS is difficult. Bill Nelson says, on April 3rd, we will reveal the crew for the Artemis 2 mission. 4 crew members, 3 from NASA and 1 from the Canadian Space Agency, will fly to the moon will fly together around the moon. Together they'll test SLS and Orion. We are going. Cool. How do you type with boxing gloves on? They don't. Oh, here we go.
Welcome back to the webcast of the Falcon 9 mission,
Atticus.
carrying the OneWeb Launch 17 mission satellites for our customer OneWeb. Now, we've had a nominal mission so far. Falcon 9 launched on time at 2:13 p.m. Eastern Time from Space Launch Complex 40 at Cape Canaveral. And we did successfully recover that first stage back on landing zone 1. This marked the 13th landing for this booster, and the second stage did complete its first burn successfully.
Yes, Okami, I do. If we keep going on
Now
this
we're just
path.
about 20 seconds away from the second ignition of the MVAC engine, which will carry the second stage and the OneWeb Launch 17 payload into the orbit that we need to deploy the satellites. This burn is super short and should just last a few seconds here. So coming up in just about 6 seconds, let's listen in for that second burn.
I'd think they'd get the crew before they did extended objectives, Rocket Guy. But here we go. All right, green flash. Second stage ignition. Reignition is good. Just a quick pulse right there. Good. Stand by for the call for nominal orbit insertion.
Looks like we did light that second engine. We're just waiting on confirmation of...
Nominal orbit insertion.
Boom.
There it is, just that confirmation of nominal orbital insertion. So great news there. The satellites are now in an orbit that is ready for deployment.
Yeah, Doom, it sucks.
So that short burn
It's
we
hard
just
to work on
completed
stuff
is
in
actually
space.
meant to refine the orbital trajectory that the vehicle is following in space. Because at this point in the flight, the stage is completely above the atmosphere and mostly empty of propellant, it really doesn't take that much to get it moving. And so that's why that burn was so short. And as a
Notice how
reminder,
you
the
said
OneWeb
mostly
Launch
above the
17
atmosphere?
mission
See?
payload is
Cool,
still
huh?
attached to the Falcon 9's second stage. And coming up next, we have the first of 3 planned deployment sequences for the 40 total OneWeb satellites.
I mean, Rocket Guy, it's
The
not
first
like
set
they haven't
of
had the crew in
deployments
mind
will
for
deploy
Artemis 2.
14
It'll,
satellites,
you know.
and is scheduled to occur in just...
The blue line is the next orbit, Dick. Will we see the deploy?
And as a reminder, we may lose ground station coverage for at least 4 of the satellite deployments in this sequence. And if we do, the teams in the control room will likely confirm successful deployment when we reach our next ground station.
We'll get
as we
some of
orbit
them.
the Earth. Now, after completing that second MVAC burn,
They'll
we
deorbit it,
are in a
chilling.
circular orbit about 600 kilometers above
It's
the
funny
Earth's
you asked that,
surface,
Doom.
traveling about 27,000 kilometers per hour or 17,000 miles per hour. Earlier in the mission, you might have noticed
Be
that
right back.
large MVAC nozzle glowing during burn 1. Now, this actually happens because the nozzle converts some of the heat of the engine's exhaust into visible light. And this is just one of the many methods that a rocket engine can use to deal with extreme heat. As you can imagine, the exhaust from the MVAC is incredibly hot. If you're just joining us, welcome to our webcast
look,
for
the
the
moon.
OneWeb Launch 17 mission.
Neat.
So far, we have had a nominal
That was the
mission
moon.
with liftoff at
Cool, huh?
2:13 p.m. Eastern Time from Space Launch Complex 40 in Florida.
I gotta sneeze.
We had a successful recovery of the first stage for the 13th time on this booster. And so far, Stage 2 has completed
boy.
2 burns.
That was nice.
And
Oh,
in
felt
just
that
about
one.
20 seconds or so, we should be coming up on the beginning of the first payload deployment sequence.
I'm good. I'm awake. What are those particles? It's solid oxygen,
As a
Chers.
reminder, OneWeb is a connectivity wholesaler that provides connectivity solutions at scale
thought that
in
was the
pursuit of
satellite
bridging the
deploying.
digital divide around the world.
So, those little shards that are coming out are solid oxygen. What they're doing is after that Merlin engine, the Merlin vacuum engine fired, they hit it with helium again because they still got to do a deorbit burn. And if you leave the liquid oxygen inside of the engine, you're going to rust something. Liquid oxygen oxidizes things really, really fast. You think salt will ruin a car? If you live in the salt belt, you know what I'm talking about. Liquid oxygen, pouring liquid oxygen in your car, there'll be no car left in the morning. It's that hardcore. So they hit the engine with helium to get all of that crap out of there. And those shards that you see are the vent lines on the Merlin engine where all that solid oxygen comes out. Yep, there's the deploy. Now, why is it solid? Well, it's gaseous when it's inside of the motor after the motor is shut off because it boils, right? It'll evaporate. When they go to vent it out, you go from a pressurized line where it's a gas to vacuum. And the temperature basically goes off of a cliff. And in that momentary second where the temperature goes off of a cliff, it freezes. It'll freeze. It goes from gas to liquid to solid. It phase changes like that. So all these shards that you see are all the liquid oxygen coming off. Now, Yeah, it's kind of everywhere. You can see it all over the place. They're little shards of, it's not liquid oxygen, it's solid oxygen, excuse me. That's SOX, SOX. Yep, everywhere. Now, the other thing is that Falcon 9 second stage has an attitude control system on it. The attitude control system is using compressed nitrogen to steer that second stage around to get it to the proper heading for deploy. Because if you're facing the wrong direction, you go to deploy the satellites. If you ever played Kerbal, that doesn't end well. Right? So you're also seeing the outgassing from the nitrogen thrusters. And because it's going from gaseous nitrogen, cold gas nitrogen, basically outgassing into the vacuum, that gas immediately turns to liquid and then immediately freezes. So you get solid nitrogen. So those are solid nitrogen and solid oxygen flakes going all around. Yeah, it's not that big of a deal. The satellites can take a little hit from a little piece of ice like that. It's not a big deal.
Views here of these payloads as they float off into space.
Rockets wearing socks is a bad time. Well, the engines usually wear socks, Cyan. Yeah, they have heat blankets on them, and they look like socks.
OneWeb, sat Charlie 1 and Charlie 5, separation confirmed.
But it's like socks with a hole in it.
There go
and
the
that
next
hole
two.
is where the fire
C1 and
comes out.
C5 have successfully deployed.
That's kind of the same, right? What I'm saying is, if your feet smell, make sure you
Should
have
be another
socks that don't
20
have
seconds
holes
or
in
so
them.
until the next payload deploy.
Yeah, I think that's fair. Oh, the moon. There's the moon. Why purge a stage? Well, they still got to deorbit it, Willie. So they're not done yet.
OneWeb, sat Alpha 2 and Alpha 6,
Bye-bye.
separation confirmed.
There we go. 2 more satellites deployed there. Got a great shot of those satellites floating off into space. A2 and A6 have successfully deployed.
Just wash your feet? Yeah. You need proper ventilation. Just saran wrap your feet? I don't know why that doesn't sound healthy. In KSP, when I rendezvous, does the impact of docking cause the craft to go ever so slightly off its orbit? Absolutely. Everything affects everything in
So
space.
our next set of satellites should be deployed in just about a minute.
That is the precise reason why most docking ports in real life have shock absorbers on them. If you notice, you just look up some footage of Dragon docking or Soyuz or the shuttle or anything. The docking port has suspension built into it because you want to absorb that momentum. Docking port will absorb the momentum so you don't bonk the station out of alignment. Oh yeah. Now, with that being said, it doesn't absorb all of it. Doesn't absorb all of that energy. Some of it. It would be good if your station had thrusters so it could station keep in the type of orbit that it's trying to get to. That's really important. These are OneWeb satellites, tech guy. Oh, that's cool, rocket guy. Why is speed sometimes measured in meters per second in space? Velocity. It's velocity. Velocity versus speed, man. Differences. Yeah, that's the moon. Mm-hmm. Do you have any of the Lego
OneWeb,
space
sat
sets?
Bravo 4 and Bravo 8, separation
Yes, I
confirmed.
do.
Looks
No,
like we did actually
Relativity
have
didn't go.
coverage
Saturday.
of OneWeb satellites B4 and B8 deployments. So that leaves just one more set of satellites to be deployed in this sequence.
That's cool, Alex. I'll
So
read
far,
about
we
that
have
later.
deployed successfully 12 out of the 14 OneWeb satellites currently planned for this deployment sequence. Looks like we have just about another minute before we deploy that last pair of satellites for this particular sequence. On your screen is a live view of the payload adapter. It's at the very top of the second stage.
Let me see, Rocky.
You can see those OneWeb
Oh,
satellites
yeah.
attached all throughout it.
Cool.
And that glowing dot off in the background is actually one of the previous satellites that we just deployed in this sequence.
Then why was it there before you deployed the satellites, bud?
Should be deploying that last pair of satellites in about 30 seconds, but we may lose ground station coverage.
It was there before deployment, guys. It's the moon. The moon, brought to you by OneWeb.
Expected loss of signal molded.
Why don't you just give people fodder? Dude, why? Why would you do that? Oh my god. You know what? You know what? You know what? One could say that this is fuel to the fire, but, you know, they're flying, you know, in a second they're going to be over China.
And as expected, we did get
It's a balloon.
LOS, or loss of signal, before we were able to confirm successful deployment of the last 2 satellites in this deployment sequence.
Boom.
We were able to confirm deployment
Now
of
what?
12 of 14 of those satellites in this group. And as I mentioned earlier, we should be able to confirm successful deployment of the other 2 satellites when we reach the next ground station. Now, our second deployment sequence is scheduled to start around T plus 1
That's a
hour
scam!
and 14 minutes, but we likely won't have ground station coverage until about 3 minutes after that. So as I mentioned earlier, if we are able to regain ground station coverage earlier than we expect, we'll be sure to provide live views, so stay tuned for that.
Yeah, shoo.
But for now, we'll plan to come back to you live around the T plus 1 hour and 17 minute mark, so sit back and enjoy the space views.
I will. Yeah, shoo, I think you might be right. My hair's... Jeez. Dish, the Orion heat shield, it deformed in a way that didn't match their models, but they said it still... It deformed in a way that they didn't understand, but they're working on understanding it, and it wouldn't have jeopardized the mission. Now, that wouldn't have jeopardized the mission part is frankly not good enough for my taste. I would make it a thing to really understand why that heat shield did something that you didn't want it to do. You really want to make sure that the heat shield works and works the way you think it's going to work. That's kind of important. Yeah. Even if the mission still would have been fine, yeah, that behavior should be understood. And don't get me wrong, NASA knows that. They're analyzing why the heat shield did something that they didn't think it was going to do, and they'll probably incorporate that newly found information into the next flight, if I had to guess. Yeah, don't screw with the heat shields. The Artemis 1, when it came back, drummer, don't get me wrong, the Artemis 1 capsule came down fine, and if people were aboard, it would have been fine. It wouldn't have jeopardized the mission at all. But NASA said that the heat shield in the Artemis 1 presser, I got the cliff notes for it. I zoomed through it when I was reporting Kerbal bugs last night. The heat shield, now this is important to understand here. The heat shield did something that they didn't expect it to do. Okay? So, think about it like this. Say NASA was testing somebody throwing a rock up in the air. Okay? There's a way that you can figure out by, the fulcrum here of your arm, right? The mass of the rock and, length away from fulcrum, right? And the acceleration of gravity. There's a way you could, if you throw it the same way every time, right? You can figure out exactly where that rock, how high that rock's going to go, and pretty much where it's going to come down, all right? Now, don't get me wrong. NASA's not throwing rocks around. This is just an example, right? So, if we do that test and we throw the rock, right? And we said that, because I'm this far away from the rotational point, and I'm putting this much force applied to the rocket because we're this far away, throwing it up in the air, the rock's going to go 10 feet in the air, or 3 meters up in the air, right? And then it's going to come right back down, and it's going to land 10 feet or 3 meters over there, right? We're just throwing it up, and it's coming right back down, right? You can use math to basically figure out exactly where that thing's going to be at the apogee, so at its apex, at the height, and where it's going to come down. Now, don't get me wrong. There's always going to be, wind, right? Wind is kind of a big deal. There's always some kind of, variable there that even then, you could take wind into account. The wind, by, what direction's the wind going, right? What the wind is blowing this way. Is it blowing sideways? Is it going with the rock? Because if it is, it's going to push it a little bit further, right? There's basically ways you can figure out exactly what the rock's going to do with math. Now, if you go to do the test and you said the rock is going to land 3 meters that way, taking into account wind, taking into account gravity, taking into account force applied, taking into account its apex, right? And you say it's going to land 3 meters over there and it lands 4 meters over there, well, you didn't do your math right, now did you? That right there is something that didn't match your analytical model. So that means that something is different about that whole thing than what your math, you didn't do your math right. Something is different because you went to test it in the real world and you threw the rock and you said it was going to land 3 meters away and it landed 4 meters away. So now you screwed up. You have to go back through the entire process and you have to figure out why that did that. Why was it 4 meters? Was the wind blowing in the wrong direction? Did I put too much force? Maybe a taller person threw the rock instead of me with a longer arm, so they applied more force to it. You have to go back and figure out where the error is. That's hard to do. That's hard to do because we're not talking about throwing a rock 3 meters in that direction. We're talking about throwing a 25-ton capsule 370,000 kilometers that way and then having it come back down. The heat shield on Orion was fine. It made it, right? But the heat shield burned in a way that did not match the analytical models that they had. That's a problem. You best be figuring out why it did that. And don't get me wrong, they are. They absolutely are. They said they were in the press conference. They're like, we're going to learn to understand this behavior and figure out why it deformed in a way that we didn't figure out. Why the rock went further than what we predicted. That right there is called deviant engineering. Okay? Stuff like that, little discrepancies like that is like if you're playing a Tetris game, right? If you're playing a Tetris game and you left a 4x1 slot for the 4x1 piece and you go to put it down and you didn't rotate it and it just blocks the thing. Now you screwed up. You're not dead, but you screwed up. Right? It's like when you miss the slot for that 4x1 piece in a Tetris game. It's like that. Too many of those errors and you lose. So it's best to be preemptive about those errors. That's really, really important. NASA has lost the Tetris game before. Let me put it to you like that. Yeah, it wasn't fun when that happens. NASA Tetris. I often describe spaceflight. A really good, easy way to understand spaceflight is that you don't really win, you just get better at it. It's like playing Tetris. You don't win, you just get a better high score. Going to the moon is the high score right now. Okay? And that's been at the top of the arcade box for a little while. No, time to beat the damn high score. But it is still just a high score. The best case scenario is that you go there and you come back. You don't win anything. Maybe in the future when we figure out a way to mine other planets, but see what I'm saying? It's a Tetris game. You don't really win, you just get better at it. There's Tetris multiplayer nowadays, so space races, Cozy. Got it. Isn't Tetris Russian? Yeah, of course. Only the Russians would come up with a game that you could never win. Yeah, exactly, Gilly. Is there pressure to go back to the moon geopolitically? Sure. Of course. Sounds like Tarkov. Also made by Belarusians. So, yeah, Tarkov, you don't win, you just get better. It's like that. That's what spaceflight is about. That's why I think that's why there's a lot of people that like space that also like Tarkov, myself included. And it's full of cheaters, dude. It's gotten so bad lately, Bobs. I've been watching, there are other streamers that I watch play Tarkov, and I'm just like, that's hacks. Okay. They gotta go back to the moon to get rid of the evidence. Never played Tarkov? Good. Don't. Hey, Ilya's like, hey, what's up? That's me. Hey, I tried to tune in at 12, but you weren't streaming. Did you delay because of the launch? I started the stream right at noontime Eastern, Hog. He's like, hey guys, what's up? Only you would make a game that you just get better at and you can never win. That is sadistic, dude. You're nuts. Tarkov's not good. Too many cheaters, bro. I gave up, dude. I stopped playing it because there was this one time I was playing a map, dude, and I saw some guy's fingernail like 200 yards away, and he capped me in the head like through a window. Like I was just walking down a hallway, and I'm just like, I'm done with this. No way. Like I looked out I was looking through a doorway out the window, and about 200 yards away, there's a guy, and I just see his elbow lean out, and I'm just like, You know, like, there's a chance that that's probably not hacks, but I'm just like, dude, I don't have the time to commit to this game to be good at it. Even if there is hackers, like, screw that. Sorry, I dropped the cap. Can we rewatch the landing? Yeah, sure, man. Yes, I am, precisely. Here, you guys want to see the landing? Watch this. We had some excellent landing footage.
Stage 2 FTS is saved.
Yeah, Summit, dude. Summit's
Stage 1.
disgustingly good at first-person shooters.
Start of our
Look at this.
stage 1
Green flash. Oh. See, I'd rather put effort towards learning and understanding what that's doing. That's much more productive in my mind.
On the right-hand side of your screen. Incredible views from first stage. Coming down on
Stage
landing
1
zone.
landing line deploy.
That doesn't suck. If you guys want to see something cool, first stage landed here, and landing former Complex 14, or Complex 13, excuse me, is literally down the street from Complex 16. See those 4 poles over there in the transporter erector? That's relativity. We spent all day watching that rocket yesterday. It's pretty crazy in my mind that, you know, Falcon 9's coming back down and landed. We could literally see the rocket launch that we were watching being streamed yesterday. Right there. There's Terran. It's right there on the pad. Isn't that cool? That just blows my mind, dude. It's like, oh, yeah, there's Terran 1. Oh, yeah, it's just chilling over there. When are you going to attempt to land a first stage in KSP? I don't know, dude. Did John get a picture of, Oh, he did. So John Krause, the Chadliest launch photographer of all time, literally got a picture of Falcon 9 landing with Terran 1 in the foreground. That was entirely on purpose. Yeah, see? Rockets taking off, rockets landing, man. It's crazy. Crazy. I love it. What's that big thing further to the right? I'll desert that Slick 37B, Delta 4's launch pad.
Welcome back to
Yeah,
the
right,
launch
Norath? It is, but with
session.
orbital rockets. Isn't that crazy?
So far, we've had a nominal mission with an on-time liftoff,
Yeah, dude.
first stage landing, 2 second stage burns, and successful deployment confirmation from 12 OneWeb satellites. We did have LOS just before the last 2 deployments in the first deployment sequence, so we are still waiting for confirmation on those. During this blackout period, we also should have started our second payload deployment sequence around the T+1 hour and 14-minute
Yeah,
mark.
she's out over
Once
Siberia
we
right
regain
now.
connection to our second stage shortly, our operators
Like
on
a
console
spaceport,
should be able
Chris.
to confirm the satellites that deployed during the blackout period, and we should be able to bring you
Indeed.
live views of the rest of the satellites set to deploy in this sequence.
Cyan, if we keep going on the trajectory that we're going, that's going to happen a lot sooner rather than a lot later, man. I mean, dude, if you told me 5 years ago that we would get a rocket launch every 4 days from SpaceX, I would have looked at you like you were nuts. Like, I would guess like once every 2 weeks, not every 4 freaking days. SpaceX has launched 16 missions. 16 missions already. It's just barely March. That's ridiculous. Like, that's literally every 4 days. That's unbelievable. That's an unbelievable launch cadence. And the crazy part about that is, that's just SpaceX. That's just SpaceX. That doesn't even include everybody else. We have a reacquisition of signal through Svalbard. There you go. Another sat deploy.
From the first set of deployments.
Yeah, Chris, every 4 days. That's absurd, man.
Delta 8 separation confirmed.
Dude, like I said, we keep going on this trajectory, you're going to see a rocket launch every day. It's going to be like plane watching, dude.
So we did get
Right, Munch? Yeah. Imagine saying, this is the future that the Apollo generation was promised. You know what I'm saying? Like, I'm just grateful we get to experience it, dude. Have you played Spaceflight Simulator yet? Nope. Why don't SpaceX use Starlink to prevent loss of signal? Well, they're above the Starlink satellites for one, Ren. 2, recertifying antennas on a flight vehicle are a really big pain in the butt. There's no point in changing it.
With the next set deploying in just about 20 seconds.
Now, with that being said, the drone ship can use Starlink. Sure, just that's fine. Yeah, absolutely. Is there a reason for loss of communications? Yes, Dumbledore. SpaceX doesn't have ground tracking stations in Russia. How big is a single one of those satellites? About the size of an engine block. These satellites are about a meter, one cubic meter, basically. About a cubic meter. They're
The Delta 3 and Delta 7 satellites have successfully deployed.
That's why Starship already has Starlink receivers. Bingo. It makes sense to certify a vehicle that's in development with those.
Final 2 satellites in this deployment sequence in just about 10 seconds here.
The Russians have ground tracking stations in Russia. Does that help? Now, see those dots right there? Those dots are other satellites, not the moon. See that? That's another satellite right there. See the difference between that and the moon that we saw a second ago? Like, there's a little bit of a difference.
Right, confirmation.
I don't know, Rudy. I don't think so. And these little smaller particles are just solid nitrogen, solid oxygen, stuff that's basically shaking off the vehicle when they deploy the satellite. Nah, that's Minmus. Shh, they don't know about that.
Of all 13 satellites in this second deployment, and so far we have successfully deployed
Yep, they have
27
an
of
AOS through
40 total
Svalbard.
satellites on today's mission.
Wicked.
Our third and final payload deployment sequence should begin around the T+1 hour and 29
Terminator,
minute
yeah.
mark, but we likely won't have ground station coverage until 3 minutes after the third deployment sequence.
Seems like it would be helpful for Starlink Mars. The Starlink antennas would not be powerful enough to get a signal out to Mars, Rudy. Yeah, heck, even the global positioning satellites wouldn't be. Not that GPS does that, but GPS or even TDRS, they're not a big enough antenna. You can't generate enough power. The antennas that we use to communicate with anything out, even to the moon, are 70-meter antennas that are on the ground. There's 3 of them. One is in California, in Goldstone, California. The other one's in Madrid, Spain, and then the last one is in Canberra. It's in Australia. 70-meter dishes. That's what you need, and that's the amount of power you need to power that dish. That's the amount of power you need to get communications out to the moon. You need a big freaking antenna. In fact, if you go to NASA DSN Now, Deep Space Network Now through NASA Eyes, you can actually see which one of those antennas is communicating with in real time. Yeah, it's not loading right now. Don't tell me we kiss a death this thing. But usually you can see what all the antennas are doing. They have what is that? Oh, updates. There you go. These are 70-meter antennas. So that's 200 feet, 200 foot wide radio antenna. These guys down here are smaller. I think those are 30 meters, but I could be wrong. This is what you need to communicate with stuff out even at the moon. You need these antennas for the moon. You need this thing for anything. You need those ones for anything longer. I mean, you don't have to use the 70. It depends on the antenna on the spacecraft too. You can use these to communicate with Mars, but the big ones are for shooting stuff that's way out there. This is what you need. No on-orbit satellite would be able to generate enough power to be able to power a dish like this. There's no way. Well, not yet at least. I'm not going to say there's no way because there's always a way, but I guess they're down for maintenance right now. GoldenEye dishes for that. Yes, it is duplicate of Savianaya. Like the transmitters in New Zealand. I've never been to New Zealand. How's she know about that? Isn't there a way to make long-range communications more effective? Optical, Gilly. Optical. Yeah, NASA's working on that right now. NASA's working on optical communications to the moon to reduce bandwidth. Or, well, to increase bandwidth, reduce transmission time. That's the right way to say it. What's that, Alex? Yeah, there you go. Yeah, exactly. You want to see how big those things are? Check this out. That is a chonker of a freaking radio antenna. Oh, deploying Starlink satellites on Mars? Yeah, that could be a thing. Sure, why not? These antennas are freaking huge, dude. Freaking huge. Hey, wait a minute. That's Gillette Stadium. Yeah, that's Gillette Stadium. All right. Nice. It's the Patriots. That's the Patriots Stadium. Hell yeah. Hell yeah. How will they play? They'll just go around it. 70 meter is about as big as we have. Hell yeah. And Franco's like, ugh. I was like, wait a minute, that stadium? I know that stadium. Sweet. It's a nice rugby pitch. So are you. It has no hitbox. You can go right through it. Oh, too real, Farah. Too real. Too real. Yeah, Denny, that's right. Yeah, of course. Of course that's how. Couldn't pass it up? No, it's all good, man. I can't really say anything, dude, right now. The Patriots freaking suck. They did not play. They were not playing very well last season. They were not playing very well. I had a key ring fall off my keys. That's what I'm working on right now here. I have to be that guy. You're good. You're good. Oh no! We suck again! Yeah, the Bruins are doing really good though, so I'm good on that front. And now, stage is currently up over the North Pole. There we go. These are my janitor keys. It's keys to all the cars. And the shop. We have our Arecibo. Or we had our Arecibo, yeah. Arecibo, yeah. Bruins are going to lose tonight? Who are they playing? I don't even know who they're playing. Edmonton. You think Edmonton is going to beat... You want more copium? I got some. I got plenty. Hey Vickers, everything's good. This has probably been asked. What do you make of the possible ULA sale? Yeah, I don't know. I always thought that Boeing would probably try to buy out ULA, but it makes, after thinking about it, it makes much more sense that Lockheed would do it. You ready for baseball season to start? Yep. Yep. Spring training already happened, dude. It's already started. Please go easy on us tonight. Yep, see, there's some solid oxygen right there. And now that I showed it, they're like, no, cut the camera. Ad time, Wolf? Alright, ad time. You guys are hitting that button, not me. If you guys didn't have, if we didn't have that stupid channel points thing, I would never hit ads, except during a rocket launch. Like, before a rocket launch, so people don't see ads during the thing. Yeah. Lockheed, yeah, I think Lockheed might buy out Boeing's share. I think that makes a lot more sense. But who knows? I don't know who buys them as long as Tory Bruno stays CEO. Well, Bandit, if Lockheed is doing what I think they're, if Lockheed's gonna buy him out, well, Tory Bruno's a Lockheed guy. Tory Bruno's ex-Lockheed Martin. So, I mean, he worked at the Skunk Works, man. Yeah, so I think I would guess they would want to retain him. Yeah, Tess, I'm kind of with you on that one. See, an interesting thing here before we get up to the last deploy, an interesting thing is that Boeing recently put in a bid for using SLS for national security launches. And now I know people are going to say like, what? But I look at that and I ask why. Why would you do that unless there was a recognized capability that NSSL Phase 3 needs? So the Department of Defense wants to launch bigger things into space. That's what I read that as, because Boeing wouldn't put that out there unless they knew they were going to get a return on investment, because it's just secretly McDonnell Douglas. But I digress. So it's a very interesting thing. You know, Boeing offering their own launch services for national security contracts when ULA has the NSSL Phase 2 contract. They're the one of two launch providers for launching the majority of national security missions into space. Why would Boeing bid against themselves? So that tells me that we might be seeing some stuff go down. Either that or the Department of Defense needs to launch bigger things into space. What are those bigger things? Don't know. Don't want to know. If I knew, I'd probably people show up at my house. Dakota and Mike just had a kerfuffle about waking up at 8 a.m. for meetings on the Discord. Oh, there we go.
And Echo 7, separation confirmed.
Yeah, Admana. I'm kind of with you on that one. Now, I'm not going to sit here and tell you that SLS wouldn't have enough power to launch like a 70-meter antenna into space that can fold up, because it absolutely would. Why would you need an antenna that big? Not for communicating with spacecraft, but that's good signals intelligence, dude. Some of the antennas that they have are gigantic on these satellites. They fold out transformer style. They're really cool.
But should be able to regain connection around the T plus
Yep.
1
See the
hour
other satellites
and
in the
32
background?
minute mark.
Those dots?
So let's tune in to watch these last satellites deploy from the second stage.
Those are the satellites over here.
And we did earlier have confirmation of successful deployment of E3 and E7 satellites.
Why the release order? Seems like they're releasing them in an odd order.
OneWeb, Sat Bravo 3, separation
Well,
confirmed.
these unlike Starlink satellites, Rudy, these things are not designed to bump into each other. They kind of just play 52 pickup with the Starlink satellites, but the Starlink satellites are designed to kind of like bounce and hit each other. These satellites are not, so you have to kind of wait before you deploy the satellites. Now, in terms of why you would deploy the bottom ones first and not the top ones, I don't know. I'm sure there's a reason why they deploy them in the sequence that they do. I just don't know what it is, dude. I'm sure there's a good reason. You know why I know there's a good reason? Because that's the way they're deploying it. It's not random. Nothing with space flight is random. Nothing. Everything is planned. So there's a reason why they're deploying those satellites that way. I just don't know what it is. My guess would be that the satellites can't bump into each other. They have to be a little ways away. But that still doesn't explain why you deploy like bottom to top or left to right or whatever. Could be the center of mass on the vehicle, Blackness. Yeah, that might have something to do with it. But I'm sure there's a really, really, really good reason for that. Give me 1 second.
As expected, we did lose our ground station coverage in the middle of this deployment sequence. There it is. You just heard that announcement. So we will be deploying another satellite here in the dark, and we will have confirmation of this deployment and the next one once we regain coverage.
OneWeb, Sat Echo 8, separation confirmed.
Looks like we did have coverage of that satellite, so just confirmed the separation of the E8.
OneWeb, Sat Echo 4, separation confirmed.
And there we go. Successful confirmation of separation of OneWeb satellite E4. As a reminder, OneWeb is a connectivity wholesaler that provides connectivity solutions at scale in pursuit of bridging the digital divide around the world. Today's mission marks OneWeb's 17th overall launch and will bring their LEO constellation to 582 satellites in space. Now, so far, we do have 34 out of the 40 satellites deployed. And coming up in just about 5 seconds or so, we should have the next set of satellites deploying.
I don't know, Sith, maybe. Yeah, I don't remember. I think so. Yeah, Thomas.
OneWeb, Sat Delta 2 and Delta 6, separation confirmed.
Thomas, who do you think I'm
And there they go.
talking
Satellite D2 and D6 have deployed. Got some great views of them floating into space there. That brings our total to 36 deployments. With only 4 left in the mission. We should be deploying the next set in just under a minute. Got some really cool views of space here. Our second stage hanging out.
Yeah, that makes sense, Aqualex. That sounds like I'd say that's
Take a
a
look
good
at the
enough
telemetry
reason.
in the bottom of your screen. We're still traveling at 27,000 kilometers per hour at an altitude of 600 kilometers above the surface of the Earth.
Yeah, supposedly having. I don't, dude. I don't bother even trying to go and read about that stuff because, yeah, I don't bother. OPSEC is important to me, so I'm just like, you know what? Maybe a dish or something. I don't know. Want to see my view of the landing today? Sure.
OneWeb, Sat Echo 2 and Echo 6, separation confirmed.
Nice launch
There we
pad
go.
in the
2 more
foreground.
OneWeb satellites have successfully been deployed. That was satellite E2 and
Signal South Texas.
E6. Now, coming up in about 20 seconds, we'll have the final 2 satellites deploying. Currently sitting at 38 out of 40 deployments.
All right, last 2.
OneWeb, Sat Echo 1 and Echo 5, separation confirmed.
There we go.
40 OneWeb spacecraft separations confirmed.
And with that call
Perfect
out, we
score.
can confirm successful deployment of all 40 OneWeb
I don't know what
satellites,
that is, Zhao.
which will wrap up our coverage for today.
All of us here at SpaceX want to give a big thank you to our customer OneWeb for entrusting us with today's
Dumbledore.
mission. We also want to give a shout out to the Range and Federal Aviation Administration for supporting
What is
today's
the
launch.
separation device?
Today's launch
spring?
includes our 215th overall SpaceX
They're
mission
firing
to
the
date
RCS
and
to dispose of
16th
the
launch
second
of the
stage.
year. And to all of our viewers,
Hitting
thanks
the-
for tuning in,
hitting
and we'll
the
see you
wrap.
again soon.
Yeah. See, what they were doing there is firing the attitude control systems on the second stage to put it into correct position for a deorbit burn. That's why the foil was flapping around there, because the RCS was firing to turn the thing. How do they know their speed? On Earth we use wheels or satellites, but in space, where we float in the dark matter? Good question, Cinnarone. You know the missile knows where it is? You know that whole meme thing? That. So the stage is in what's called an inertial. The stage, most rockets and in fact most planes have an inertial guidance system on it. Basically, they're using an accelerometer coupled with ground stations to be able to pinpoint the position. So, say you launch a rocket, right, and that rocket goes over the horizon, right? You don't have a ground station link from the pad. Now the rocket will use that pad as a reference frame, right? But when it's not in line of sight, you can't see. You don't have a signal anymore. That the rocket is flying on terminal guidance. It's flying by itself. What the rocket will do is use that accelerometer. It could be an accelerometer. It could be an inertial measuring unit, IMU. It really depends on what it is. That IMU will be able to take the acceleration of the vehicle, and it can plot its position based off of acceleration, even with no ground tracking stations. It's called terminal guidance. They call it right before the second stage goes over the horizon. When we watch a SpaceX flight, stage 1 or stage 2 is in terminal guidance. Or closed loop guidance, basically where it's using the acceleration of the vehicle to determine, based off of its last point when it had signal, it's using the acceleration of the vehicle to determine where it is. The missile knows where it is at all times. It knows this because it knows where it isn't. That's literally what that meme is about. And if you guys want to see something cool, so check this out. This is SpaceX's Texas launch site, Starbase, right? See that right there? See the tracking dish? There's 2 of them. This OneWeb mission, if you look where it was, right? If you look where it was, it's flying on a trajectory that basically goes right over Texas. See? So SpaceX has a track on that second stage from South Texas. That dish right there is tracking the second stage. I was hoping they'd keep the webcast going, but nope. So that second stage that we just saw floating around on orbit, it is currently being tracked by the South Texas launch site. Watch this dish. It'll move as the thing orbits by. Pretty cool, huh? See the dish moving? How's the acceleration measured? They could use an accelerometer or most likely an inertial measuring unit. Guys, planes do the same thing. Planes do the same thing. They have inertial guidance. You have to configure the inertial guidance system. I just like saying that. That sounds like something from Star Trek, but it's not. You have to basically tell the plane where it is. And you can use they use GPS to tell to get a point at an airport to know where the plane is, so the plane's guidance systems the autopilot can fly in the right direction. That's kind of important. You got to configure all that before you fly, especially with a plane that like has autopilot. The plane needs to know where it is, especially if autopilot is doing its autopilot thing. Yeah. Yeah, and GPS is there as well. Yeah. In fact, like the move is, they're not moving to that. They used to use radio, like ground tracking, to help figure out a plane's position. In fact, like an ILS still uses radio signals and VORs. You could still hone in on an airport from its VOR, which is just basically a beacon that's speaking the airport's ICAO code in Morse. So like, okay, I'll give you an example. So a VOR for an airport. Let's pick Toronto Pearson. The VOR for Toronto Pearson, because Toronto Pearson's airport code is YYZ. Yeah, that's what that song is about. Cool, huh? And you like Rushmore now, don't you? Yep. I want to talk hockey. Let me know when it's appropriate. Well, we got to get back into Kerbal, and we got to figure out a better way to do an Eve mission. That transfer vehicle just croaked the game again. Yeah, in fact, those chimes that you hear at the beginning of YYZ, that's the VOR. Ding, 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 ding. That's the VOR for Toronto Pearson. Rush made a song out of the VOR, which is awesome. Makes me like Rush even more. Such a good song. Nerds. I know. Ripley had a busy winter on the test stand. That's cool. So that's Ursa. Nice. Now you have to play it. Oh, come on, dude. We gotta be careful with doing this. So this noise. That's the VOR for Toronto Pearson. I'm not playing that. I'm not playing at all. Sorry, Churs. That's the most Rush thing ever, of course. YYZ. Yeah, it's Canadian, so you got to say YYZ. That's fine. I have no problem saying that. If Americans made that same song, it'd be YYZ. But it's not. So, yeah, I mean, the planes can use radio waves, they can use inertial guidance, or they can use GPS for navigation. You can actually switch that on most cockpits. On the autopilot, there's RNAV, GPS, stuff like that. Because it's the proper way of saying it. Well, it's Canadian. ZZ Top or YYZ. Yeah, there you go. Okay. We all know the popular musician ZZ Top. Oh, that doesn't sound right at all. I'm not saying that ever again. See last. This was just released from the DoD. Man, that's scary. Yeah. Guess Alberta is more American than I thought. Alberta? Yeah. Yeah, they do like their freedom up there, don't they? they do like their freedom up there. Anyway, all right, guys, let's jump back into KSP. So, unfortunately, the Eve transfer vehicle, there's something wrong with it. The vehicle just bogs down. It gets 3 FPS, even when we tried to do that transfer last night. I'm pretty sure you guys don't want to spend, 50 minutes here at 3 frames a second for simulation to see that thing go out to Eve. So let's build a better one. We're going to do that now.